So there will be some specification for that. And then there are SLO groups which are related to cost. Tariq already talked a lot about it. And then the third aspect is that we want to do verification that SLOs are met. So some machinery will be needed where we may use OAM functionality to verify that your SLOs for a particular slices are met. We did not go deeper into those that functionality, but when we talk about OAM, that should also be considered from the overall slicing use case perspective.
Yep. There is a section that Loa pointed, he had concerns of the coexistence of multiple features, IOEM with network slicing, for example. How does it influence the requirements? Indeed, towards the end is where he added, and we think, as you were mentioning, Kiran, that there are cases where multiple of those features may be required in the same packet. So in the same packet, we might require network slicing as action and an IOEM action at the same time.
Well, yes, that's the good one. Have we ever actually spotted anyone that they are exclusive?
Exclusive? I
think if I introduce this one, I can never introduce this other one. That's what concerns me most.
Okay. No, I did not think. Well, I don't know if anybody has a good idea of why, if one is present, the other should not. But the presence of multiple, we thought of.
I can give you one more example where presence of two different things might be needed. Again, in slicing context, you may need path selection and cost group for transport network. And then if you're, let's say, talking about 5G core and you want to go from one service function to the other, that's where you will need NSH kind of functionality. So they have to coexist in the same network slicing context.
Yeah, I don't think that's problematic. The thing that two things can't coexist is what concerns me most.
It seems to me that
Lord, don't you think that these are mechanisms or like a tool set, each operator's choice, whether they want to use programming construct or NSH construct. So their coexistence will be defined at a higher plane.
Could be. Could be.
I have a question. So when you mention NSH-like programmability or service function in MPLS data plane, are you referring to RFC 8595?
8595. Which one is that? I don't know.
It's what can be characterized as SFC MPLS. So it defines the base unit that are presented by two label elements. It can work in swapping and stacking mode and then mix mode. And it does emulate the NSH because it has SPI and
I think I added use case for the NSH. What I mean is another RFC which defines the standard NSH format, which can be carried.
Yes, but it's 8300. But so I think that, again, there are different solutions, and I think that will be helpful if you're explicit about what solution you try to address, because 8595 uses MPL label elements to emulate the NSH. If you intend to include NSH native header, as defined by RFC 8300, I think that will be helpful if that will be explicitly mentioned.
I think when you mention NSH, it means the RFC 8300. I've got the number, but that's another way. Yeah, you are right. There was a way to support SFC using the MPLS label only. But if we want to support the native SRH, it's subs function header. We need to use the extension header to carry it, and it brings some other benefits like the capability to carry the metadata, right?
Well, that's the question: is do we really want to have this capability, and if then why?
Oh,
So
I said
why?
there's some benefits because for many service functions, you need to pass some parameters or some metadata, but the current MPLS-based solution doesn't have that capability.
Yes, but again, if MPLS is used as a transport between SFFs, then why do we need the P router of this transport tunnel to be aware of the payload and NSH in particular? So I don't see the case there. And if we want to have MPLS end-to-end, why not to use 8595? Which explains how the SFF can process SFC information expressed in a label element.
I mean, a lot of this is about converting MPLS from a very elegant protocol that works to another protocol by importing essentially the warts that IP has chosen to adopt.
We jumped to the NSH discussion, and I wanted to capture what your inputs are in the minutes. I'm afraid that we'll lose it. So, do we want to stick to the order, or I can go back to the SFC and then capture what Greg said about it and what you are saying as well, Stewart.
I just wanted to point is that last meeting we talked about Stuart presented a very pragmatic approach, and I think that especially this discussion on SFC and which way to do SFC and what we need to consider and find the solution, it's important because if the proposal is that we must carry the NSH as defined by RFC 8300, then the logical question is the why. And why P router must process the NSH.
Okay. Okay, I added that. So,
well, I'm supposing the P router had to handle the packet in a particular way that needed some parameters. Latency is one obvious case.
Well, I think that the tunnel should be engineered if it's delay and packet loss critical or sensitive, then the transport has to be engineered in a particular way. So yes, if it's a DetNet or DetNet-like environment, that can be expressed in a transport, not in a payload. So again, their payload will be mapped in appropriate DetNet flow, and then the P router can operate on the DetNet flow.
Yep. Yep.
Okay.
Are we talking about .NET or SFC?
It's an example. So again, .NET as an example of transport or delay and packet loss sensitive applications.
I mean, isn't the MPLS label determine how you forward the packet? Okay, then it's used to define the path, which is
no. An MPLS label is to design is there to express the forwarding equivalent class, and that is more than just the path.
Okay, but this also can just indicate the chain itself, right? From one service function to another service function. Then you need to carry actual information, like the path ID to identify the flow, and some metadata exchanged between the service function nodes. So that information cannot be carried by the previous.
No, the metadata. I disagree. So if we're talking about SFC, you have SPI, and SPI defines your service function chain. Yes, you can have a local classifier to do reclassification in an inner SFF, and that will rewrite your SPI. But again, I don't see how the P router must be aware of it. So you only do that at the SFF. And SFF selects their tunnel to reach the next SFF.
So in the limiting case, every router is looking at the NSH, isn't it? In the limiting case, if you have to steer through every hop and set the parameter on every hop.
Well, if we assume that every router is SFF, then yes, then we have one hop tunnels.
Yep. Actually, we have one hop PHP to tunnels.
Yeah, it could be, but again, it's different functions. So
yes.
There is a transport and there is a SFF.
Okay. Do we want to capture an action item on this? Maybe why you or we can close this if we see that this use case is not bringing in any new requirements, and that's fine. But if anyone thinks that it is still a useful feature, we can add it to the an action item.
It could be interesting in the intellectual exercise, but I don't see it's practical.
Yeah, I wanted to hear any.
Tariq, I would prefer to keep it open for now because I don't know how we are thinking of supporting service functions and network slices. And right now, I don't know how that will fix in the current discussions. So it's better to brainstorm on it a little bit more.
I have no objection to it staying open.
Okay.
Okay, all right. I heard someone else. Was it you that was speaking? I am not sure.
I think it was Stuart.
Okay, no. I mean, he was pro the SFC idea.
That's I added there. So the basic logic, I think, is that since there's already a RFC for supporting SFC in MPLS, then why not just support the native NSH in MPLS? Because previously there's no solution for that. But if we have extension headers, we can include that, and it offers some extra benefits by allowing to carry the extra metadata. So if we find some information must be exchanged between the adjacent service functions, then that seems you need that capability.
Okay, that sounds good. I will move a little bit faster to give the others on the agenda a chance. So Time-sensitive networking is another use case that we looked at, and in here a packet is traversing multiple routers, and every router is given a timestamp, which is a deadline by which it needs to adhere to. Okay, and we thought that we can embed the deadline timestamp inside the label stack. That's one option. So every segment or that needs, the packet needs to traverse multiple segments, for example, or multiple LSPs, is followed with a timestamp expected to be maintained, or the deadline timestamp. So here is a stack of labels, the transport label 1, followed by FAI, and then a timestamp for this segment, and then another forwarding label with FAI and another segment timestamp. The other approach we thought of, it's a challenge. If you look at it, it's challenging to have a 64-bit timestamp embedded inside the label stack. So yeah, cramming in the accurate timestamp might not be the best inside the label stack. So we thought, okay, what if we carry timestamps after the bottom of stack, and we just have alert of its presence in the label stack? So I think this is inspired from a previous discussion, not new. This is not new. I think it was talked about in Stewart's proposal about the pointers. And
so are the timestamp for recording purpose, or are they actually going to affect your path selection?
Both, I think, and more. So they're also going to determine whether you kill the packet because it's not going to get there on time.
Okay, well, I'm not sure if it makes sense to use timestamp to select your path selection, because that may introduce other issues. Kill the packet, that's reasonable, or maybe we just let the packet go all the way to the path to the end, and let the end drop it. Why not worry about it in the middle?
Because it's burning bandwidth that is contributing to the delay of its friends behind.
But it also means that the transit routers need to do more work. That is checking parsing the extension header, and then or traversing labels.
Yeah, I think it all depends on whether how time critical some of these things are. But it does seem to be. We need to work through the applications in some detail, but it does seem to be silly to clog up the network with packets you're going to throw away and then have to throw some more away because you clogged up the network.
Okay, well, yeah, I think to kill the packets, I think that's sort of reasonable, but using the timestamp to select paths.
Well, so there is something else that you might want to do, and that's to use a PIFO. And you can't use a PIFO. So for those that don't know, a PIFO is a push-in first out, and the idea is that you queue the packet in a place in the queue such that it's likely to survive that hop within the time that's allowed.
yeah, it's a different from the queues that most routers have, right?
Right, but it's one of the queues that the research community is looking at to address better latency.
There's all I say is there's multiple ways to give the timing informations. One is using deadline, another is using time budget. There might be some other possibilities. So if we want support such kind of time-sensitive application, we'd better make that generic to support different scenarios and make it extensible. So note, like here, we just define one way to do that. That I don't think that's a way to go. Rather, actually, this is a very similar to the segment routing idea. Basically, you define the path, and each path, each segment, you have some time budget that need to process. So in that sense, I think this kind of information can be carried as some metadata for in that case. So, and also we should support different semantics for the timing information. Like a deadline, like a budget, or something like that. So so I think if this use case is useful, it's can be combined with others, and or use a more generic way to support that.
Now, so I have two concerns here. Let's say that for the same flow, if the first package has a deadline, and the second package has the same slightly different deadline or the same, but the arriving time is different. So if you use a deadline timestamp to affect path selection, the same router may send them onto different paths, and that could cause other issues. That's one concern. The second concern is if you put a timestamp in the label stack. Now, each label entry has that bottom stack bit. Now that timestamp could have that bit position set to be 1. And now if a router just the router will likely to just treat that timestamp as a bottom stack label, right?
Just to clarify, in here there's no multiple bottom stack set. I mean, it's a continuation of a single label stack.
Right, but they're saying that for example, that timestamp 1 could have that bit set, right?
Which bit?
The bottom stack bit set because of that particular time value.
No. That's what I'm trying to say. These labels don't have the bottom stack bit set. Most likely, it's the bottom here that would. Depending on which approach. So there are two that we thought of, and we're not advocating one over the other. One was the timestamp sits inside the label stack. The other is the timestamps sit outside the label stack inside an extension header. So depending on which one you are talking about, it might have different. I don't know what do you mean.
So I think all we can do today is to record these various notions and analyze the merits as more information becomes available to steer us to the overall solution.
Makes sense. By me, no problem.
Just to clarify, if you look at the first one, the timestamp 1 is in the stack, right? So
yes,
that is a 32-bit entry, right?
No, who knows how many bits? I mean, Yakov was suggesting it could be more than that.
Yeah, that's the thing.
Whatever it's whether it's a 32 or 64 bits, but one of the bits will happen to be the BOS bit, right?
Yeah, so you better not write that in a strange way.
So that's really very strange. I don't recommend that way to use this label.
Right. So I mean, there are challenges here. We are already flagging that 64 bits is one challenge because you need multiple labels. Another is within one label you cannot write into the 32 bits. I agree. Maybe you should limit where you can write the timestamp. And
two comments.
Yeah.
So Balázs was speaking. The first comment is regarding the timestamp size. So with 31-bit timestamp, you can cover 2 seconds. 2 seconds in time-sensitive communication is practically forever.
Oh, sorry, what units? What nanosecond per nanosecond quanta?
Yeah, you have the nanosecond accuracy, but every 2 seconds your timestamp will circulate.
Yeah,
in time in that case is practically forever. So you have much lower requirements.
Yeah, if you need more than 2 seconds, you're probably not in the right game.
Yeah.
Although I suppose a packet could get stalled due to some fault, and then you'd have to purge the queue, ideally purge the queue before continuing. So if you could recognize those packets, you could purge them to stop the wraparound.
So that was just one comment.
Yeah.
With 31 bits, you can be fine. The other comment, please do not use time-sensitive networking terminology here. It is used extensively in IEEE. There is a TSN, time-sensitive networking workgroup. So please use like time-bounded networking or time-sensitive communication or whatever else. Otherwise, there will be many, many confusions.
Okay, wow, that's news to me. I don't know who was speaking.
Well, shouldn't isn't the
Balance.
generic term time-sensitive networking and your technology IEEE time-sensitive networking? Time-sensitive, you can't have the whole. I don't think you can have the generic term time-sensitive networking. I don't think the rest of the universe has agreed to that.
I'm just saying what people are already using in layer 2 network quite extensively. In time-sensitive networking, they are referring to a lot of functionalities, which is not here the functionality you are speaking about. So the general term, in my understanding, is time-sensitive communication. Then you don't have this issue. And try to have an issue if you can avoid it.
No, I'm fine with communications going in there. Okay.
Yeah, call it time-sensitive packet or time-sensitive communication.
Time-sensitive communication sounds better, but I think probably the correct differentiator is also IEEE TSN.
Another question here is, why would you have 2 timestamps in the packet?
Because you might want to deliver it by a certain deadline at 2 different points in the network.
Do you really care about that, or you just care about the final?
Well, you might have, supposing you have a relatively congested pair of links in the network, you might decide that if it's not got across this first one by a certain time, you can kill it. And then you might wish to kill it in order to preserve bandwidth for others. And you might also take the same point at another point in the transition in the transit.
But yeah, I don't feel the network should have that level of control to the packet. Actually, I think only the end-to-end delays matters, and also each. I can see each router can based on the overall budget to do something about it, but when you if you want to define the budget and each section each node before you send the packet, I think that's too much you ask for from the network.
Well, I mean, I think that's a personal opinion. You're entitled to that opinion. We need to analyze the characteristics and constraints of the network, and I think there are use cases where you might decide that if a packet doesn't make it by a certain time, for the good of everyone else, it's to be killed. I mean, that's no different from the original concept of TTL that goes back to RFC 791, which was actually really TTL, but it was in units of seconds.
Mm. Okay. I think we're, I have to leave in another 8 minutes. I want to cover 2 more use cases very quickly. One is segment routing header. Today in MPLS, you can embed a segment routing header as a SID list, as a list of MPLS labels.
Yep.
But those are consumed by the segment endpoints, so the label stack gets depleted by the time the packet reaches its destination. There was a thought that a SRH can sit in an extension header, and then a copy from the SRH for the next segment can be copied to the top of stack. I don't know how realistic is this. I'm not coming up with it, but it's one idea that was one use case that was flagged. So the idea is to copy from the extension header SRH to the top of stack, just like SRV6.
Right. So this is basically the operation is very similar to the SRH in IPv6. So the issue about the current SR MPLS solution that first, the label stack can be very deep based on the number of the segments. Second, there's no way to carry actual information like the bits for network programming in SRv6. So if we can just put the SRH
is that actually the case? I'm just challenging you because MPLS has a way of doing network programming that predates anything that IP did.
So what I mean is, the similar mechanics used in SRv6. So also in the SRH, there could have other options, TLVs to extend it. So which means in the SRH you can imagine it can carry more information, but that's not possible by the using the MPLS label alone. The way if we have SRH, we can keep a very short label stack, right? Each time we just copy a new label to the label stack, and
I mean there are many techniques.
Sorry to interrupt. So currently SRH defines the seeds with 128 bits long identifier. How, including SRH?
Here I use SRH. That's not the same as a SRv6 SRH. It's designed for MPLS. For example, the seed maybe is only the label length, the MPLS label.
But that will be SR-MPLS. SR-MPLS does that already.
Yeah, but we hold all the stack in the SRH instead of put them directly in the label stack.
What is the benefit of that?
I already said that you can do network programming along with you can assign actual bits information to each label. And you can
are you saying that SR-MPLS does not do label network programming?
No, I mean right now you just use one label to indicate one segment. That's one label. One label is only give you 20 bits or something. You can do nothing more than that. But now I can put give each segment a block of data, maybe 128 bit, maybe even longer than that. I don't know, but the case is the thing is that the first 20 bit will be used as a label, and the remaining bits you can use that for different purpose, such as network programming.
But that's what phi does, right?
Right. So that's the idea, is to embed a function, a pointer to a function, and possibly arguments after it, and the phi will alert of the data being there. I think the extension header. So it's all boils down to the same two options here. Either the phi is sitting in the label stack with data with the forwarding actions coming after it, or the phi is pointing to the forwarding action which is sitting after the bottom of stack. So these are the two things that it's coming back to this discussion where either it's sitting inside or sitting outside the label stack. Yeah, that seems to me like we're talking about network programming either inside the label stack or outside the label stack.
So it's good to keep such kind of header into a standalone header after the label stack, because when for the parsing, each MPLS label will be one state in the parser. So if you have a very deep label stack, that will take many cycles to parse. If you want to reach the the higher layer, it needs many more states in the parsing parser. But if you keep each of these functions just in the extension header and keeps the label stack very short, then that will be benefit for the performance.
Okay.
But if you want to use different files and to with different pointers to different extension headers, that makes it very complicated.
Yeah. I agree. I don't support that kind of solution. We just use a flat label stack and plus an indicator, then plus a chain of extension header. That's the most simple solution, and also it's good for the performance. If we want to use various pointers in the label stack, I don't think that's actually complicates the parser and the processing. So I don't think that's a good idea.
Okay, I think this is a good discussion for the design team when they're coming up with a solution. I think I went over all of what we wanted to present, me and Kiran. I will leave the floor, for you to continue. I do have to drop, but feel free to continue on this. I have to stop sharing. If somebody wants to share their screen, please go ahead. Loa, anything before I adjourn?
I think you have to look at action items and write something to the mailing list on the status of that.
Yeah, I did update it on my side, but I didn't get a chance today to go over the. But let me do that by email. Sure.
Okay.
All right. Thank you. Have a good day.
My feeling now is that we don't want to push Jeffrey out of the agenda one more time. So we conclude this discussion here. We know we're not finished. We will come back to it, but we should swap over to Jeffrey and his presentation now. Is that okay with everyone? Silence says agreement. Okay.
Yes, Loa, let's just do it.
Yeah. Jeffrey, you have.
Should I share?
You should. If you want to talk to the wiki page, you can share the wiki page.
Okay, I'll share my wiki page then.
Hmm?
Oops. Can you see my screen now?
I don't see anything.
Try again.
Not yet, no.
That's you. Okay, can someone else share for me? I'm having trouble.
Okay, let's see if I can find it.
I don't see.
One sec. If someone finds this faster than I do, just go ahead and share it. It's data after the boss, right?
Yes.
Okay. And then share. And I would like to share. I think it's this one. Nothing happened. What? There, can you see something?
Viewing Lower Anderson something or other. Blank page. That's it. See it now.
Okay. So, Jeffrey, you have to guide me how to move around.
Okay. Okay. So if we just go to the top of the wiki page. So very quickly, at least the current practices for data after BOS, we have three scenarios: upper layer payloads, pseudo-wire control world, and then cache header. And recently, they're having three proposals that I'm tracking. One is MPLS extension headers that comes after the BOS label, and also the generic delivery functions, basically trying to achieve some functions that are applicable to many layers, including MPLS and others like beer or even Ethernet, if we decide, if people accept that idea. And then finally, there's the IOAN. All this would have metadata come after the BOS. I have one observation here is that the MPLS extension headers in Howie's drafts can be also used for generic functions in the 2B scenario. So with that consideration, 2A and 2B, they are very much aligned, and we can actually use that same to cover the IOM as well. Basically, the IOM data will be put into the MPLS extension header. So that based on that observation, we basically I'm proposing to combine 2A and 2B together. So basically using the MPLS extension headers, and that can be used for both MPLS specific functions and the generic functions. So currently, the extension header use graph use next header pointer, and I remember there were discussions whether we should use TLB or use next headers. I would prefer that next header structure. It aligns better with IPv6 headers. There is a counter argument for TLA structure in that it will be easier to remove a header if it's in the TLB style. But I realized this morning that typically all the TLVs are put into a container, and you have a size for that container. So when you remove, well, it's easier to remove a TLV, and you would have to change the container size, and that becomes difficult as well. So if you consider that, there's really not much difference between the TLV structure or the next header structure. So that's just something I thought of this morning. Okay, so I am moving to the how to do we indicate that there is metadata after the bottom stack label. I think this is very much aligned to a latest email from Loa on the mailing list. We would use a special label. In fact, a base special label. We refer to it as F5. Even for hop, well, whether it's for hop functions or like end-to-end, we use a file label. And okay, so this paragraph here, it was written some time ago. I think at that time, people were talking about there may be multiple files in the stack. I think it's still that's still the case. We are talking about multiple files, but even with that, files on the closer to the top of stack, when it comes to the bottom stack, we will still use another file with a bottom stack's bit set to clearly indicate the presence of metadata headers, extension headers. Now, in the existing MPLS extension header proposal, I want to point out one thing, that they have a header of headers idea that allows quickly skipping to the skipping all the headers and to the real payload. I think some are not in favor of that. I forgot who and for what reason. I thought I just flagged that. I think it's a good idea to allow the quick skipping to the real payload. On the other hand, if you have to remove a header by a transit router, then that also means that you have to update a header of headers. That's just something to keep in mind. Now, also in the email discussion, and I'll summarize it by Lo. I think there were people saying that we should not touch a gal or gash. I'm fine with that, but I realized one thing, that it was pointed out that today, as long as a gal label is present in the label stack, then the bottom of the stack, the data after bottom stack will be treated as gash. So that may cause some trouble.
We did discuss this last week, didn't we? And one of the things that I think we need to decide is, can a classical gash be in the same packet as one of these new things? If the answer is yes, then we better figure out how they coexist. If the answer is no, then we will have to re-implement the gash functionality and make sure that all new routers, as it were, or new capability routers, don't put a gash in. I don't think it's very difficult, though. You could easily make one of these things here be a gash.
Right. So assuming that we have to support the coexistence of both gash and new metadata in the same packet, then there are two ways to do that. I mentioned in my email to Lo this morning. In this wiki page, I only talk about one option, but there is another option. But anyway, here, one thing we could do is that using the gal label, but using a different version or the enable value for the new metadata.
Alternatively, you could use one of your own indicators instead of a gal, and you could make this header, as we can see in this page here, actually this header type is ACH, and then you could have the ACH in its content where the variable per this header is.
Right, I agree. There are two ways, here, this wiki page was written quite a few weeks ago.
Sure.
Yeah, so here I only listed the GAL option. But either way, whether it's using the existing GAL label or using the new label, we need to handle the case where we both have the cache and other metadata present. I mentioned that in the email, the two options. Yeah. Okay. Now I'm coming to the open questions. The open questions was summarized by Tarek some time ago. The first one is it a requirement to have multiple ancillary data correspond to a different file? This, I think we talked about it earlier today. Here, I basically pointed out the issue that that ancillary data, if they are not following a BOS label, then they could be treated by some LSRs as labels, and then the BOS bit may cause trouble there. So here I'm saying that if we always put the ancillary data after the BOS label, and even if you need to have multiple ancillary data blocks, there you would just treat it as if there were multiple label stacks, one following each other, another one. That's one way to do it. And that way you don't need to worry about BOS bit at all. Your file always have that BOS bit set if it has this ancillary data following. And if you need to have more, then you just think of it, it's another label stack following it. The next open question, the question was the size of a header should be fixed, or it can be incrementally changing hop by hop. I think we talked about that as well. I guess it all depends on whether the hardware can easily insert or just update in bits. If it's not easy, maybe we can mandate that the ingress leave enough space or not. So there's just some thoughts here. There is no need to make a decision here. The next two questions, I don't have answers to the last one. I think Tarek provided some answer to the second to last one. I put it here, but I don't have any thoughts here. So that's basically what I have for this wiki page. Questions, comments? Hello, can you still hear me?
Yeah, yes, of course we can. As tempting as it is to say no when someone asks that question.
So if no questions or comments, then I'm done then.
Okay. So I stop sharing this. And I need to So we have like 10 minutes left. I told Tarek to take care of item number 3 and do a mail to the mailing list. Please read, especially if you think you have something that you need to report on, if you have an action item. I'm not sure what I want to do now, but since we don't have much time, I think we should say that the mail I sent out and what I put in the wiki, what I call the convergence platform, please read and comment on the mailing list and see where we are. And then we should discuss the liaison to 3GPP instead, because it should be known before we send it out. Let's see if I can find it. There. So let's see, I'll go back and share again. Here. And I want to. Now you see something. So what you see is a two-part item. The first one that is between the start and end is a proposed liaison to 3GPP, actually to seek their advice on the scaling of network slicing and identifiers and what we need to consider. We need to send this, and that's what I asked Gonzalo. Gonzalo is the IETF liaison manager to 3GPP. I asked him for the instance where we should send this.
So I think David Lake gave me a pointer, which I forwarded to you. There's a sort of central collection point for liaisons in 3GPP.
Ah, okay.
If you look on that page I sent, then that email I sent with the University of Surrey discussion, there is a pointer in there about where to send it.
I'll go and look and see if I can find it. So if I find it, I will send it there. And I will actually need to send it through the IETF liaison statement.
Yes.
Tool. So I hope that works. So any comments on the actual text?
So the TS working group has been working with on slicing for a while. I thought they would have got the answer similar for this question from 3GPP before.
Well, let's find and see if there's a liaison. Why don't we look and see if there's a liaison from BGPP?
I can go and look, but then you don't see anything because I've been. Can anyone?
I've never noticed anything in the stuff I've been doing on VPN Plus.
So let's agree on that. This we need to have in a formal way from 3GPP. If that doesn't exist, even though there are a lot of knowledge within IETF at different places, then we need to actually have a response from 3GPP.
So if 3GPP have sent it, they'll simply say, you realise this was already answered some time ago. On the other hand, I don't think we want to hear other than direct from the horse's mouth, as it were. We want to know what their thoughts are on this value, because it's completely critical to the way we do the design.
True.
So let's ask their advice. The worst they'll say is, we can't tell you, we don't know ourselves, or the answer's huge, but yeah, I don't think it's harmful to send them the message, and it shows that we are interested in working with them to understand important characteristics.
So, can I ask, are there any opposition to actually sending the liaison?
There was a liaison on the 14th of the 8th of 2014, 2018.
About 3 years ago, yeah.
What was that?
What was it about?
Network slicing.
Okay.
No, hang on. Reply liaison statement, IETF work related to the management and orchestration of network slicing. That's not quite the same thing. We're after their thoughts on data plane sizing, which is not the same, is it?
No.
Well, I see no harm in sending the request for information. The worst they'll say is, we sent it to you 5 years ago, in which case, in which they will either confirm or deny whether it is correct still.
Yeah. Okay.
So we should
So
send it to them.
unless someone speaks up now, I will send the liaison. I'll be trying to find out where to send it.
And it's somewhere like liaisons at 3GPP or something.
Okay.
I sent it to you, did I not, from here?
We don't need to solve that now. I will find it. It's fine. So, okay, I'll stop sharing this.
Right.
Loa, I'm just thinking out loud that we are working on network slices in T's work group as well. And so should this request be specific to MPLS, or you might want to involve T's team as well, or at least T's working group chairs, and ask them if they are CC'd on the request? And those scale for network slice identifiers may not be just limited to MPLS. T's is looking at other aspects, other transport mechanisms also.
I thought the size of the identifier was specific to network slicing.
It's specific to our implementation of network slicing, isn't it? We need to know the answer. We need to know whether it's more or less than 256, I think, because there is a suggestion that we'll use the TTL field to store it.
True.
So it's 3GPP liaison at etsy.org is where it needs to go.
Okay. Kieran, I will copy the T shares when I send out the liaison, and they can add the information they think is necessary.
That would be great. Thank you.
Thanks.
Yes, we're back.
So we're running out of time. We have 2 minutes left. I will send the liaison as soon as I can. Anything else if we need to? And please read my mail and respond to that, because it's an attempt to make some type of progress. I had some feedback from Stuart, and I think I got what he said, but I'm not certain I agree. But go to the mailing list. Okay, so we close the meeting here. Thank you for attending, and there will be a meeting next week, probably much like this one. Okay, bye-bye.